For 8085 microprocessor to be able to work properly, it needs some external devices. One of them is latch and the other is a 3 to 8 decoder. The reason that it needs the latch is because it is multiplexing or giving two tasks to the 8 bits, which we call the AD0 to AD7. It wants these 8 bits to carry both address and data. We already explained that the way that 8085 works is that whenever it wants to communicate with I/O or memory, first it puts the address or selects the memory cell that it wants to communicate data with, and then depending on the read or write, it would either tell the memory cell to put the data, tell the memory to put the data which has already been selected, the data in the memory cell that has already been selected on the data bus to read it, or would put some data on the 8 bits of data to be written in the memory cell which has already been selected again. So it uses a latch. The way that latch works is in this way. This is an enable pin. 8 bit of data here and 8 bit of output here. If this enable pin is 0, the input is completely disconnected. If this is 1, whatever is in the input would be written on the output. So anything that the CPU does, it first needs to put the address, right? It first needs to select the memory cell that we are talking about. So it would put the lower byte of the address on AD0 to AD7. Then the enable pin is connected to a pin which we call in the 8085, which we call address latch enable. This would go high. We said when this goes high, the way that latch works is that anything which is written in the input would go on the output. So we have A0 to A7 here. A8 to A15 would always have its separate wires. Then in the next clock, the ALE would go low, so input is disconnected from the output, meaning the changing in the input wouldn't affect the output. Now we are getting the wires, these output wires separately, so we put the data on it. Now I explain how this exactly works in the rest of this lecture, but first let's talk about the 3 to 8 decoder as well. Everything that you see in the computer, from the player which is playing a video to the browser that you are browsing different web pages to the operating system itself, are programs. And programs are a set of instructions which are part of the IS of the CPU, the instructions that the CPU understands. So you implement, or the idea in your mind is called a program. Using a set of instructions that the CPU understands, you write your program. These set of instructions, all of them, are done using some steps which we call machine cycles. We said these machine cycles include fetch, read, and write. But we have two writes, which we call them memory read. We have two reads, which we call them memory read and IO read. Well, as the name suggests, if the CPU is working with the memory, it would be memory read. If it's working with the IO, it would be the IO read. The same thing about the write, memory write or IO write. How are they different? Where they are different in these pins. They are connected as the three inputs of a 3 to 8 decoder. Now imagine the CPU wants to read from the memory. If it wants to read from the memory, the read is active low. It needs to provide a 0 here, a 1 on the right, and a 0 on IOM. As you see, M is active low. 1, 0, 0. The output of the decoder here would be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. So if we zoom, this wire is actually saying that this is a memory read. So we would connect this wire that we are talking about, this memory read, to the RD pin of all the memory chips that we are working with. If you are working with the IO devices, we need the IO read and IO write to be connected to the corresponding pins on different chips. So you interface different memories in this way, or any device, any IO device in this way. If you want to do the IO read, this would be connected to the read pin of those IO devices. If you want to interface memory chips, the memory write and memory read would be connected to, again, corresponding pins of RD and WR, which are active low. If you look here, the decoder, we have a not here to say that any line that is activated, we actually mean it is equal to 0. All the other lines would be equal to 1. So when we talk about, now you could obviously work out the logic about all the other output pins of this decoder as well, but right now we want to understand how the interfacing of 8085 microprocessor works with different chips. First of all, A8 to A15 is connected through this bus, and then we say AD0 to AD7. We say AD0 to AD7. Here is the input latch. ALE at the first clock would go high. A0 to A7 would be written on the output. A0 to A7 and A8 to A15. I have shown all of them in this way, but I am separating them out in different ways. All my chips are 4K, 4 kilobyte chips in this example. So A0 to A11, A0 to A11, and A0 to A11. From this wire and this wires, set of wires are connected to the address bus of all of my memory chips. Then I have A15, A14, A13, and A12 connected to these 3 NAND gates in this way that you are seeing, and the output of the NAND gate would go to the chip select of all of my memory chips. Now my data bus, which is the same thing from the same pins, which is taken from the same pins. My address bus is already completed and connected to the address bus of all of the chips. Since the ALE is going low, the output of this latch would never change again in the same machine cycle. So now we are having the data bus connected to the data bus lines, and if you see, it works in a two-way communication. It is connected to the data bus of all of these pins as well, and then we have a set of control pins here, which the memory read and memory write would be connected to the corresponding pins of all of my memory as well. Again, now let's see the address space of all of these memory chips, even though we talked about them in the first module as well. The first NAND gate, the first memory chip, let's see how it would be activated. Chip select is active low, so we need a 0 here. This 0 is the output of this NAND gate, and the NAND gate works, the logic of the NAND gate works in this way, that all the inputs need to go high. So we need to have 4 ones here. These 4 ones are A12 to A15 through a NOT gate, so we need to have 4 zeros here. So A15, A14, A13, and A12, we need 4 zeros to be activated. The rest could be from 12 zeros to 12 ones. Therefore, in hex, the address space of this would be 0000 to 0FFF. This is the first 4 kilobyte which is allocated for this first chip. The second one, all the A12 to A15 are connected to this to the input of NAND gate. Again, it is connected to this chip select. It needs to be 0. We have a 0 here. We need to have 4 ones in order to have a 0. So all of these things need to be 4 ones. The rest could be, then then I say the rest, because I explain all of these things in the first module. I'm just going on all of these things fast. But you know that A12 to A15, for this memory chip to work, they need to all be ones. Then A0 to A11 would choose one of the 4 kilobyte memory cells in this chip, and when it is selected, The CPU would provide the RD or WR that we would be explaining in the next lecture, and then the RAM would either put the data that has been already selected using these lines on the data bus, or would read the data out of it, which would be called the CPU, the memory write. Actually, it depends whether you are talking on behalf of the memory or the CPU, but you understand what I'm saying. So the address space here would obviously be from F000 to FFF. And finally, we get to the last chip, to this chip, which chip select again needs to be 0 for this chip to be activated. So it is the output of this NAND gate, and this NAND gate has these inputs need to be 1, 1, 1, 1, but this one is connected to a NOT gate, so we need to have a 0 here. 1, 1, 0, 1. We need to have A15, A14, 13, and 12 as 1, 1, 0, 1. The rest could be from 12 zeros to 12 ones. This would be D 0, 0, 0 to D F, 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 would be the 4 kilobyte of the address space of this last chip. So explaining all of these, now we want to talk about what do we mean, how all of these things work, that we say the 8085 is doing the fetching, read, write, all of this communication that we have been explaining. In the next lecture, we are going to finally explain them one by one, which is the concept of the machine cycles.